Hey, let's do some percent problems in the real world so that you in the real world can do percent problems. Let's get started, except for, there we go. All right, we're going to work on using a variety of strategies to solve real world percent problems. Here is how I would solve a problem that was a percent problem that I didn't quite know. Are we working on finding the whole or the part of the percent? I would, at the very start, if I saw the word percent or I saw the symbol for a percent, so I knew it was a percent problem, the very first thing I would do is I would set it up the ratio way. That way, I could figure out if I was looking for the part, the whole, or the percent. Once I know, is this a part, a whole, or a percent problem, then I could decide what strategy to use to solve the problem. What strategies am I talking about, you ask? Well, let's review what we've talked about this chapter. We have talked about if we know the part and the whole, so if we know that it's like 5/8 and we need to find the percent of 5/8, well, we can fraction Hating troll it, or we can set it up the ratio way, right? If we know the percent and we know the whole, but we don't know the part, well, in that case, there's lots of things we can do for these type of problems. Yes, we can solve it the ratio way. We could also change this percent into a decimal and then times it by the whole. We could do it the double number line. If it's like 10% or 50% of a number, we could do it the mental math way. So that's if we're looking for the part. Now, if we know the percent and we know the part, but we're looking for the whole, if that's the case, then we kind of only have two strategies. We could definitely solve it the ratio way, or we could set up a double number line and solve it that way, right? So today we're going to set everything up percent over 100, part over whole, and then we're going to decide from there what strategy to use. And we may use more than one strategy to check our work, which will be very beneficial. All right, let's go to the first problem. Manuel found a wrecked Trans Am that he could fix. He bought the car for 65% of the original price of $7,200. What did he pay for the car? Immediately, let's do that 65 over 100. And then this other, is that the part that he paid for, or is that the whole original price? It is the whole total price, correct? He bought it for the 65%. That's what he actually paid for the vehicle. Okay, my battery is running low. We'll see if we make it through. So let's figure this out. Because we are looking for the part, we can do it in any of these ways, correct? If I'm looking for the ratio way, I'm not seeing anything super awesome. So what I might decide to do is I might decide to do it the decimal way instead, which means I will change the 65/100ths, 65 over 100, to 65/100ths, right? Change it to a decimal and then times. Okay, oh, honestly, I could have times by 72, huh? So you decide what you would like to do. 5 times 0 is 0, 5 times 0 is 0, 5 times 2 is 10, 5 times 7 is 35, plus 1 is 36. Then add a 0, 6 times 0 is 0, 6 times 0 is 0, 6 times 2 is 12, 6 times 7 is 42, 43, 0, 0, 0, 8, 6, 4. Make sure that I scoop my decimal in. Would it make sense to say that he only paid $4,680 for the car? Well, if the original was this much and he bought it for 65% of the original amount, then yeah, This is less than the original amount, and he paid less than the full price, right? 65% of it. So that makes sense to me. So that is how you could do it. Now, if you would have done 65 times 72, you would have also gotten 4,680. Okay, let's go on to the next problem. Mrs. Conley asks her class what kind of party they want to have to celebrate their excellent behavior. Out of all the students in the class, 5 want an ice cream party, 7 want a movie party, 10 want a costume party, and the rest are undecided. If 20% want an ice cream party, how many students are in the class? Okay, so I do have a percent. It is the percent that want ice cream. So if this is the percent that want ice cream, then I need to have the part that like ice cream, right? And it was 5 people wanted an ice cream party. And that's just the part that wanted ice cream, right? The 20% part that wanted ice cream. I'm going to leave that there. And it's asking how many total students are in class, right? So it makes sense that the whole is what we're looking for. So if we're looking for the whole, we've got 2 options. We can do it the ratio way or the double number line way. I'm going to try the ratio way first. If that's tricky for me, I'll go to double number line. But I'm going to stick with the ratio because I can see here that there is a divide by 4 relationship. So I'm going to do the exact same thing here. 100 divided by 4 is 25. Would it make sense to say that there are 25 total students in class? Yeah, that's right, because 5 plus 7 plus 10, that'd give you like 20 something. So, and then a few that are undecided. 25 students sounds correct. Like it. Jerry, an electrician, worked 8 months out of the year. What percent of the year did he work? Ah, this is a percent problem. So I know I can go percent over 100, part over a whole. Oh, I don't have anything that has a percent sign, does it? In fact, it asks, what is the percent? And golly, it just looks like I have one other number, right? 8 months out of the year. So that's the part that he worked. But what's the whole? 8 months out of the year? Hold on. How many months are there in a year? What are the total number of months in a year? There are 12 months in a year. Yay! All right, so what we've got here is we're looking for the percent, which means I can keep it the ratio way and solve it that way, or I can fractionate control that 8/12. What do I want to do? Don't see anything there, don't see anything here, so I may just decide to do the fractionate control. You know what I could have done? I could have simplified this. That would have given me 2/3. That still isn't very helpful, is it? To try and find a relationship. So let's keep going with the fractionating control. 8, 80, 12 will go into 80, 72 is 6, right? And that will be 80, which will be 6 again. I know what's happening. We have a repeating decimal, don't we? So that's the decimal. They want the percent. So I got to scoop it twice. I could either put 66 repeating 0.6, or I could round it to just 67% of the year he worked, which makes sense. More than 50%. 50% of the year would be 6 months out of the year, right? He worked more than that. He worked 8 months. So it's going to be more than 50%. Those are definitely more than 50%. Luke and Matthew ran a lemonade stand on Saturday. They agreed that Matthew would get 60% of the profit because the lemonade stand was his idea. They made a profit of $25. How much money did Matthew make? All right, I'm just going to start with that 60 over 100. Now I'll look at this 25. Is that the whole that they earned, or is that the part that Matthew made? They made a profit of 25. So that's the total they made, isn't it? So it's going to go on the bottom. That's not the part that Matthew made. That's what both of them made all together. So that's going to be put on the bottom. So I'm looking for the part, right? That means I can do it the decimal way, double number line, mental math, ratio way. So many of you love the decimal way, and that's the way you would set it up, huh? I am going to go with the ratio way because I can see we are getting a times by 4 relationship. But to get to P, we need to get smaller because 25 is smaller than 100. So we're actually dividing by 24, aren't we? 4 into 60 is 15. So I believe that Matthew made $15. That makes sense. Is that 60% of 25? Yeah, that makes sense to me because it's got to be more than half. Because 60% is more than 50%, and 15 is more than half of the total of 25. So I believe that Matthew made $15 and Luke would have made $10. Suppose there are 20 marbles in a bag and 5 of them are blue. What percent of the marbles are blue? We got a percent problem. Percent over 100. This is another one. What percent of the marbles are? It totally died on me, but we're good. Hopefully. Looks like I'm kind of frozen. We're going to keep going then. So what percent of the marbles are blue? Well, we know 5 of them are blue. We definitely know that the part is blue. And we know that there are a total of 20 marbles in the bag. We could fractionate and control this, or we can see that there's a relationship there, or even a relationship there. Which one do I want to go with? I'm going to go with this one. I'm going to go with the times by 5 relationship to get here. So I get 25. Would it make sense? 25% of the marbles are blue. I like that. If there were 170 people at the concert and 85% of the seats were filled, how many seats are in the auditorium? Immediately put that percent over 100. Now we got to decide, is that 170 people part of the people or all of the people? Well, there were 170 people at the concert, and we want to know how many total seats are in the auditorium. So we just know how many people were actually at the concert, not how many total people could fit in the auditorium. That's what it's asking us. It's asking us how many people, how many seats are in the auditorium. So I can't do it the decimal way. It's not going to work to change 85% to a decimal times by 170. We'll get a bogus answer. We'll get something less than 170, and that's not true. There's more than 170 seats in the auditorium. So what we can do is either the double number line or we can do it the ratio way. So I'm going to see if we can do it the ratio way. I'm going to see if 85 goes into 170. I wonder if it's double. It is. Ha! It looks suspicious to me, and I was right. So 85 times 2 is 170. 100 times 2 is 200. Would it make sense to say that there are 200 seats in the auditorium? Yeah, because there's 100 people that are there. It's not all the way full, it's mostly full. So 200 seats sounds great. Great. All right, you ready to try some on your own? Remember to set it up the ratio way, and then you can kind of decide how to solve it. Here's your first question. A coin contains 9 grams of nickel and 16 grams of copper for a total weight of 25 grams. What percentage of the metal in the coin is copper? All right, well, there's the copper, and that's just the part, right? We want to know what the percent is. How am I going to find the total? Should I add it all up? 9 plus 16 plus 25. Let's see what that gives us. 11, 20, right? 15, yeah. 2, 4, 5, 50. Okay, so it's 16 grams that are copper out of a total of 50 grams for the entire coin. So I'm going to keep this the ratio way because I can just times by 2 times by 2 16 times 2 is 32. 32% of the metal in the coin is copper. Did you get it? Let's try one more. Kate has made 20 free throws in basketball games this year. That is 80% of the free throws that she has attempted. To find the total number of free throws she attempted, Kate wrote this out. I love that she did 80% over 100. So what error did Kate make? She got the 80% correct, didn't she? She got the 80 over 100. So my question is the 20 right here. Is that in the correct spot? Is 20 the total number of free throws that she attempted? Or is 20 just the part that she made? Well, it says that she made 20 free throws. That's not all of the ones that she made and missed, just the ones that she made, which is only 80%. So she should have set up the problem where 20 is the part that she made, not the total. It even tells you that it's asking for what is the total number of free throws. So what error did Kate make? She may put 20 as the whole amount of attempted free throws when really 20 was just the part that Kate made. Okay, so give it a shot. Do a lot of practice and a lot of deciding which strategies you like best so you can become really fluent at it and really pave those trails in your mind for whatever strategy you like best. All right, friends, I will see you next time.